this is Mrs. Guest with your homework for tonight. As I indicated in class, I'm looking for you to review the video and stop, pause, rewind, fast forward, whatever you need to do to capture the notes I identify in your notebook. In case you weren't here today in class, we did cover a number of terms. I'll flash up the screens or the slides with that information for you here. Also, if you didn't capture all the notes or you want to check that you got all the notes, if you were in class today, you have the opportunity to do that too. So three key terms here. First, statistics, then individuals, and then what a variable is. So please make sure that you have these in your notes. Next, we also talked in class about quantitative variables versus qualitative variables. So if you can make sure you have these in your notes as well, that will be important. Moving on, the new information to put into your notes per this homework tonight starts with population data versus sample data. So population data is data from every individual of interest, where sample data is data from only some of the individuals or objects of interest. Down at the bottom here, we see that a population parameter would be a numerical measure that describes an aspect of the population, while a sample statistic is a numerical measure that describes an aspect of a sample. Okay, so let's give some examples here. We talked about Mount Everest and conducting a study regarding Mount Everest and those who climb Mount Everest in class today. If we were looking at finding, say, something about every single person who's ever climbed Mount Everest, we'd be talking about population data, right? Every single person would be included. But if we were to look at information about every 10th person who climbed Mount Everest, let's say, that would be a sample, right? A subset of those who climbed Mount Everest. So if we were interested in the average height of everyone who climbed Mount Everest, that would be a numerical measure describing the entire population. We'd call that a population parameter. But the average height of every 10th person who climbed Mount Everest, that would be a numerical measure about a subset of the population, so we'd call that a sample statistic. Okay, continuing forward here, let's see if we can get to the next set of information. All right, I'd like you to capture information about levels of measurement. So we're talking about different ways that we can describe data, different types of measurements of data. Now there are actually levels of those measurements, ranging from nominal all the way up to ratio. So I know there's a lot of words here. Use your good note-taking skills to simplify, but I would like you to get information about each of these into your notebook. So starting with the nominal level of measurement, this would apply to data where we're talking about names or labels or categories. So, for example, it could be colors of crayons, red, yellow, green. There's no particular significance to the order. There wouldn't be any reason to try to order from smallest to largest or least to greatest. We just have no means to do that. If we're in that sort of situation, that would be a nominal level of measurement. The next one is ordinal level of measurement. This is where we would start to order the data. For example, class rankings, 1, 2, 3, 4, 5. There's an order to those. But the differences between each data measurement, say between the first ranked individual in the class and the second ranked individual in the class, this isn't something we could easily calculate. How much better is the first ranked person than the second ranked person, or the fourth ranked person than the fifth ranked person? There's no consistent difference there between those rankings. The first person might be somebody who has a 0.01 higher GPA than the second ranked person. But the fourth ranked person might have a 0.5 higher GPA than the fifth ranked person. There's no consistency there. So we can order them, but there is no meaning to the differences between those rankings. They don't tell us how much better somebody is than somebody else. Then we go to interval levels of measurement. So here we've got data that can be arranged in order, just like the ordinal, but now we can calculate differences between the data values, and they do have consistency and meaning. So we'll look at some examples of those in class tomorrow. And then finally, the ratio level of measurement, which is the most specific and detailed level of measurement. This is one where data can be arranged in order. Differences can be found between data values that have meaning, and we can even calculate ratios, and we'll review what ratios are in class tomorrow, but we can calculate ratios because there is a true zero to the measurement, and we'll talk about what that really means tomorrow as well. Okay, so please make sure you have these definitions in your notebook, at least for us to start from. Moving forward, I'd also like you to capture this part here at the bottom about the levels of measurement and some of the detail about suitable calculations. So it just gives a little more specific. So nominal, again, we can put data into categories. Ordinal, we can order data maybe from smallest to largest or worst to best or the other way around. But each data value can be compared with another data value in some sort of significant way. Interval, we're still ordering the data just like in ordinal, but now we can find meaningful differences between data values. We can calculate differences that mean something. So for example, we could say one data value is 5 more than or 12 less than another data value, and that means something meaningful. And then finally, ratio. We can order the data, we can find differences that have meaning, and we can also find ratios between data values. And again, we'll come up with a number of examples of these, and we can discuss and debate where we think different types of data might fall. All right, lastly, in your notes, I would like you to capture information about descriptive statistics and inferential statistics. This is something that will serve as a basis for discussions we'll have going forward. When we're talking about working with data measurements and what we do with them, if we're talking about descriptive statistics, this is where we're using some methods of organizing or picturizing, that's a new word, picturing or summarizing information from samples or populations. And there are a number of ways we can do that that we'll explore in this course. Whereas inferential statistics, now we're looking specifically at information from a sample, but we're going to use that information from the sample to reach some conclusions about the entire population. So we just want to get that into our notebooks now because we'll be referring to that going forward. Okay, so that's your task for the homework here, to capture those notes. Please make sure that your notes are complete, and we'll see you in class tomorrow.